Hello everyone and welcome to day 7 of Jamb Physics in 40 days. Jamb Physics in 40 days is a series that is brought to you by Oyalen, where we believe that when you dedicate within 30 to 45 minutes of your time daily, you'll be well on your way to acquire all the necessary skills and tools that will enable you to ace Jamb Physics. So if you're a Jamb candidate who is preparing for the exams, and physics is one of the subjects that you have selected amongst your subject combination, then this video is definitely for you. And I would like to implore you to please check it out from day 1, as we have explored different topics in each of those days up until now. Day 1 has its own topic, day 2 has it like that, and this is day 7. And the topic we are looking at in day 7 is friction. So please check out the videos. And don't forget to like and share the video amongst all your friends also who are preparing for the exams. You just might be helping somebody to score a very good grade in Jamb Physics. So please like and share. The day 7 video is about friction, and what Jamb expects every candidate to have covered as far as friction is concerned are listed here. So they expect that you should be able to solve problems on static and dynamic friction. You should understand what static friction is, what dynamic friction is, how to solve problems that involve static friction, and how to solve problems that involve dynamic friction. They also expect that you should be able to solve for the coefficient of limiting friction. Depending on different cases, if the object is on a horizontal plane, if it's on an inclined plane, and all of that, you should be able to find the coefficient of limiting friction. They still expect that you should be able to know the advantages and disadvantages of friction. I'm sure you know that friction does not only come with disadvantages, there are also many advantages to it. So you should be able to list the advantages and disadvantages of friction. Jamb also expect that you should be able to mention the different measures by which you can reduce the effect of friction or the action of friction on an object or a body. They also expect that you should be able to define viscosity and terminal velocity. And finally, they expect you to be able to apply the Stokes law. Now, for deeper explanation of each of these subtopics of friction, you can check out our video on friction where we explain each of these in details. But as far as this video goes, we're going to be solving problems that cut across all the subtopics in friction that have been set in Jamb from their past question. So get your materials ready and then let's solve some past questions on friction. This question says, if an object just begins to slide on a surface inclined at 30 degrees to the horizontal, the coefficient of friction is... Now, from our study of friction, you should recall that frictional force F is given as the product of the coefficient of friction and normal reaction. And when it is inclined, right, on an inclined plane, frictional force F is given as mg sine theta, while the normal reaction is given as mg cos theta. So if we are looking for the coefficient of friction here, this will be given as F over R, which is mg sine theta over mg cos theta. So you see mg cancels mg. So we have sine theta over cos theta, which is the same thing as tan theta. So let's find tan theta. Theta is 30 degrees, and this will give you 1 over sod 3. So the correct option is option D. The friction due to air mass can be reduced by... to reduce friction, there are several methods that could be used, which include lubricating, streamlining, polishing, use of ball bearing, amongst others. Now, but in this case, our focus is on due to air mass. Like for example, when a car is traveling at high speed, the body needs to be streamlined in order to enable it go through that massive air without building so much drag force due to frictional forces. So to reduce drag, you need to streamline such an object. So the correct option in this case is option A. This question from the UTME 2024 says the tangential force acting on an object that opposes it from sliding freely on the adjacent side is called. Now, to get an understanding of this, let's draw an inclined plane on which we have an object of mass m. Okay. Now, the force that keeps this from sliding down goes in this direction, and that is known as the frictional force, which is mg sine theta. And the force that is acting in this direction here is called the normal reaction R. And we know R is mg cos theta. While the force acting downward from here is the weight, which is mg. Now take note, this is parallel to the plane, also known as the tangential force. This is perpendicular to the plane, known as normal reaction. Now this is just the weight, the force acting downward, known as weight. So we've looked at normal force, that's the normal reaction. This one is perpendicular. The frictional force is parallel, and the weight is downward. But upthrust is the force that acts on an object that is either partially or completely immersed in a fluid. Now that force tends to push it upwards, therefore causing a weight loss in that object when it is partially or fully immersed. So in this case, the one that is the tangential force is the one that is acting parallel. So hence the frictional force is the correct answer. So we go with B. This question from the 2023 UTME exam says, a 400 Newton box is being pushed across a level floor at a constant speed by a force P of 100 newtons at 30 degrees to the horizontal, as shown in the diagram. Now, what is the coefficient of kinetic friction between the box and the floor? Now, when we take a look at this diagram here, we know that the effective force, that is, let's start here, solution. The effective force that is pushing this box, let's call that F. It will equal the x component of P right, and we'll subtract the frictional force between this box and the level floor. So frictional force. Now when we consider this here, what we have therefore is, now remember F here can be MA, but F equals mass times acceleration, and in the question we are told that the box is pushed at constant speed. There's somewhere in the question it says constant speed. Yeah, here, at constant speed. So that means acceleration here is 0. So we can say 0 equals P of x minus frictional force. So we can then say P of x equals frictional force. But also, we know that frictional force equals coefficient of friction and normal reaction. So, and the question is asking us to find this coefficient of friction. So let's continue. P of x is therefore coefficient of friction times normal reaction. So from here now we can then say our coefficient of friction equals P of x over normal reaction. Now what is P of x? P of x, let's resolve the horizontal component of P here. That would be P cos theta over, now what is this R here? To get the value of the normal reaction, we have to know that the weight acting here is W downwards, but the weight acting upward is the normal reaction. But this is not the only weight that acts downward. There's also this here in this direction, which is P of y. So R is therefore P of y plus W. So let's put that there. P of y plus W. Now let's solve this. P is 100, so we have 100 cos 30 divided by P of y. P of y will be 100 now sine 30 plus W, which is 400. So now let's continue. This would give us 100 times cos 30 is 0.866, and 100 times 0.866 would give us, at the numerator here we'll have 86.6. So now let's go to denominator here. 100 times sine 30. Sine 30 is 0.5. 0.5 times 100 will give you 50 plus 400. So here we have 450. So coefficient of friction can then be solved at 86.6 divided by 450, and that will give you 0.19. So the correct option here is A. Which of the following statements about friction is not correct? So let's read through the statement and pick out which is true and which is false. So statement A, the force of kinetic friction is less than the force of static friction. Yes, this is true because you require a much larger force to be able to set an object to begin to move, because you have to first overcome static friction. Then once you have overcome the static friction, the amount of force required to keep it in motion is definitely less than the amount of force that actually starts the motion. So this is true. B, the force of kinetic friction between two surfaces is independent of the areas in contact, provided that the normal reaction is unchanged. Yes, this is also another true statement, because friction does not depend on the area of the surface, but instead it depends on the nature of surface. That is, whether the surface is smooth or rough. And we know that when it is rough, the frictional force is larger. But when it is smooth, the frictional force is close to 0. So yes, this is also true. Statement C says, the force of rolling friction between two surfaces is less than the force of sliding friction. This is also true, which is why for rolling friction we often use things like ball bearings or wheels, because it's much easier for those to overcome the frictional force, keeping them static. So that is why it is less than the sliding friction. This is true. This leaves us with just one more. Now, the angle of friction is the angle between the normal reaction and the force of friction. Now, this is false. This is false because the angle of friction is actually the angle between the resultant. You must first resolve the resultant of the normal reaction and the force of friction. So it is the angle it makes with the resultant of these two to the normal reaction that makes what we call the angle of friction, not the normal reaction and the frictional force themselves. So this is false. The correct option is therefore option D. A force of 16 Newton applied to a 4.0 kilogram block that rests on a smooth horizontal surface. What is the velocity at t equals 5 seconds? Now, we are given the force, we are given the mass. What we now need is time. What we need is velocity. We already have time is 5 seconds. So we can apply the equation where F equals mass times acceleration, which would imply that we have mass into change in velocity, V minus U over T. Now, at the initial, the velocity is going to be 0. So when we apply that, we'll say the force, which is 16 newtons, equals mass, which is 4 kilograms, into V minus 0 over 5. So from here we can then say V equals 5 times 16 over 4. Now 4 here 1, 4 here 4. 5 times 4, that gives us 20. So 20.0 meters per second. Now from the options, that is option C. When a box of mass 45 kg is given an initial speed of 5 meters per second, it slides along a horizontal floor a distance of 3 meters before coming to rest. What is the coefficient of kinetic friction between the box and the floor? Now, in this case here, we're going to apply F equals coefficient of kinetic friction and then normal reaction. But we know that F is also mass times acceleration, and normal reaction is mass times acceleration due to gravity. So if we put that into this equation, we'll be having MA equals coefficient of kinetic friction multiplied by mass multiplied by acceleration due to gravity. So you see here M cancel M. So A should be coefficient of kinetic friction and gravity. So the coefficient of kinetic friction would then be A over G. So how can we get A? Now acceleration is change in velocity over time. Now considering the question that we have here, so we know that the box is given an initial speed of 5 meters per second and it slides along a horizontal floor a distance of 3 meters before coming to rest. So now let's apply that here. So from what we have in the question, we can solve this part here. We have that the displacement S is 3 meters and the initial velocity U is given as 5 meters per second. And since what we observe from this question is that the object is going to come to a final stop after the 3 meters is completed. So that is V is 0 at this point. So when we apply V squared equals U squared plus 2AS, we can find an equation for A here. So if this is 0, 0 equals U squared plus 2AS. That is, we can say 2AS equals, as a negative 2AS equals U squared. And then A therefore can then be negative U squared over 2S. So we apply this for A. So let's solve that here now. A therefore becomes the negative sign and then U squared. U is 5. So 5 squared over 2S. 2 times S is 3. So what we have here is negative 25 over 6. Now this negative sign is only telling us that it is a retardation, right? It does not have anything to do on the magnitude per se, as it can be both positive or negative. Positive when there is uniform acceleration, negative when there is uniform retardation. So that's just what the negative sign is doing here. So now let's go on to find this. We can now apply this. So without the negative sign, we would have 25 over 6 divided by G, which is 10. So from here, we can then write and say coefficient of kinetic friction is 25 over 6 times 10. That is, we have 25 over 60. Now, when we divide this, we can break it down since our answer is in fraction. Now, what can go here is 5. 5 goes here 5 times. 5 goes here 12 times. So our final answer is 5 over 12, which is option B. The coefficient of static friction, this ought to be friction. All right, friction between a 40 kilogram crate and concrete surface is 0.25. Find the magnitude of the minimum force needed to keep the crate stationary on the concrete base inclined at 45 degrees to the horizontal. Now the force required is going to be the frictional force, which is mg sine theta minus coefficient of static friction multiplied by normal reaction cos theta. So in this case, this is the effect of friction. So you have to subtract that from the frictional force itself. So in this case, what we'll have is mg. M is 40 times g, which is 10, times sine 45 degrees minus coefficient of static friction, that is 0.25, times r, which is also mg. So that will be 40 times 10, then cos 45 degrees. Now what this gives us is 400 times sine 45 is 0.707 minus, now this is 1 over 4 times 400, that is 100. So 100 times cos 45 is also 0.707. Now when we multiply this and then we divide, when we multiply this and we subtract them from each other, we'll end up with 212.3 newtons. That is approximately 212 newtons, making the correct option D. Calculate the magnitude of the force required to just move a 20 kilogram object along a horizontal surface if the coefficient of friction is 0.2. Solution. The force required to overcome static friction is the product of the coefficient of static friction and the normal reaction. And we know that normal reaction is mass times acceleration due to gravity. So we can then say F equals coefficient of static friction multiplied by mass multiplied by acceleration due to gravity. Now, the coefficient of static friction is given as 0.2 here. Now we multiply that by the mass. The mass is given as 20 kilograms. And then we multiply that by acceleration due to gravity, that is 10. Now when we multiply all of this, we're going to arrive at, now 20 times 10 is 200. 200 times 0.2 will give you 40. So we have 40 newtons. The correct option is therefore option B. A bead traveling on a straight wire is brought to rest at 0.2 meters by friction. If the mass of the bead is 0.01 kilogram and the coefficient of friction between the bead and the wire is 0.1, determine the work done by friction. Before I go on to solve this question, if you're yet to subscribe to the channel, I would like to implore you to please do so, because when you subscribe, you're helping us to be able to make more helpful videos like this for everyone that would definitely need it. So please do subscribe and also hit the notification bell icon so that you get alerted every time we put out a new content. And also you can download the Exam Fun app on the Google Play Store or on the Apple Store to practice with so many questions that are there on the app. It is created in such a way that you'll have fun even when you solve questions. And to make it even more interesting, you can also earn as you learn. So please download the Exam Fun app today. And of course, if you also have any questions on what we have been solving so far, don't forget to put that in the comment section. We'll definitely attend to all of your questions. Now let's get back to this question. From what we see here, let's bring out all the parameters we're given. We're given the displacement S as 0.2 meters. We're given the mass of the bead as 0.01 kilograms. We're given the coefficient of friction as 0.1. And we are asked to find the work done by friction. Now, work done is force times distance or displacement. Remember, this is in the direction of the force. And this force here is the frictional force F, which is a coefficient of static friction multiplied by normal reaction. And we also know that normal reaction is mass times gravity. So let's put everything together. So we say that work done is therefore coefficient of static friction, that's 0.1, multiplied by mass. The mass is given as 0.01, multiplied by gravity, that is 10, multiplied by the displacement, 0.2. Now let's tidy all of this up. Now 0.1 times 0.01 will give you 0.001. So times 0.2 times 10. And from here, our final answer in standard form will be 2 times 10 raised to the power minus 3. And work done is measured in joules. So our answer is 2 times 10 raised to the power minus 3 joules. The correct answer is in option B. This question says a 100-kilogram box is pushed along a road with a force of 500 newtons. If the box moves with a uniform velocity, the coefficient of friction between the box and the road is. From the equation where force equals coefficient of friction multiplied by normal reaction, we can then say that coefficient of friction, being the subject of the formula, is F over R. And we know that R is mg. So let's apply that. So our answer would then be F, which is 500 newtons, divided by the mass, 100, times acceleration due to gravity, taken as 10. This would then be 500 divided by 1000. And we know the coefficient of friction does not have unit, so we just break this down, and this will give us 1 over 2, or 0.5. So from the options provided, the correct one is option D. The terminal velocity of a ball bearing falling through a viscous fluid is reached when the. Now, let's assume this to be a jar containing a certain amount of a viscous fluid. And then you take a ball bearing and drop it into it. Now, what you're going to observe is that the ball bearing will begin to accelerate down the viscous fluid, but at a particular time, it stops accelerating and starts moving down at constant velocity before it then later starts retarding and then stops at a point, right? So you see that point where it has uniform velocity is the point where we call the terminal velocity, as it is defined as the maximum constant velocity of a particle falling through a viscous fluid. So in this case, the answer would be velocity is uniform. So we go with option D. Which of the following could be effectively used to reduce friction? Now, when trying to reduce friction, there are a number of ways that we can do that. One of them is by applying lubricant, or in a process known as lubrication. That's one of the methods. Another way is also to do what we call the streamlining. Another way is to use ball bearing. Another way is polishing, where you make the surfaces smoother. But when we look at the options here, we see that they are fluids. So in that case, that means we have to be applying lubrication in this case. And the property that makes a good lubricant is the viscosity of that fluid, the lubricant itself. So when we consider these options here, we have kerosene, grease, water, and petrol. Even though they can reduce friction, because of their viscosity, however, kerosene, water, and petrol will not effectively reduce friction. So the only one that can effectively do that is grease. So we go with option B. In this question, we are asked the coefficient of friction between two perfectly smooth surfaces is. Now, when we consider the conditions for friction to occur, You must have two particles that are moving at relative motion with each other. And then, of course, friction also depends on the nature of the surface. Mind you, it does not depend on the area of the surface, but depends on the nature. And what we mean by nature of the surface is that whether the surface is smooth or whether it is rough. And the rougher the surface, the more the coefficient of friction. That is, when you have rough surfaces, the friction there is always high. But when the surfaces are smooth, the friction is very low. But in this question, we are told that the surfaces are perfectly smooth. So it is not just low. In this case, it is 0. So the correct answer in this case is D. This question says, the friction which exists between two layers of liquids in relative motion is called. Now, when we consider the options provided, capillarity defines the tendency of a fluid to either move upwards or downwards a narrow tube. So in this case, it does not define what we have in the question, so it is knocked off. Option B says surface tension, which is the ability of the surface of a liquid or a fluid to act as a stretched elastic surface. That is when you stretch a skin, elastic skin, the surface of a fluid acting like that is what we call surface tension. And it does not describe what is in the question, so it is not the answer as well. And then viscosity is the ability of fluids to resist flow. That is when they are resisting the motion of one over the other. And that is also what we define as friction, when you resist movement or resist motion, right? So in this case, the answer is viscosity. We'll go with option C. However, for D, cohesion describes the ability of the molecules of a particular substance to stick together. When the molecules have a strong force binding them together, we say that they have cohesion. Now, I hope that with the question we have solved so far, we've been able to help you to solve as many that concerns friction. But to practice more, you can download the Exam Fund app that is available on Google Play Store and the Apple Store. Now, that app is created in such a way that it makes your learning experience very much fun. So please download, register, and have fun while you learn, solving more questions from physics to every other subject that you love. And as always, I also like to inform you that you should please subscribe to the channel. Please do so. When you subscribe to the channel, you help us to be able to make more helpful videos like this. And if you want us to continue to do this, please subscribe and also share the videos amongst your friends so that they too can have access to the wonderful things that we are doing on this channel. So like, share, and subscribe, and I'll definitely see you in the next video. Thank you.